This is slightly different, just a short little video to talk about families of straight lines and to go through a couple of examples. So we can talk about a group of straight lines as a family if they have all got the same value of m, so the same gradient, or if they've all got the same value of c, their y-intercept. For example, this group on the left here, they've all got different values of c, but they've all got a gradient of 3. So we can generalize that family as y equals 3x plus c, some value of c. Just the same, this other group on the right here, they've all got different gradients, but they've all got a y-intercept of 4. So we can generalize these as y equals mx plus 4. We don't know what m is, but we know that it's going to go have a y-intercept of 4. These unknown values, or the m and the c that we've generalized as not knowing, we refer to them as parameters. And questions might sometimes ask you to work with your equations without actually giving you a value of m or c. So they're a little bit more abstract. So we're going to do a couple of examples just to show you how those work. So example 1 is similar to when we are finding the equation of a line and we know the point it's going through. This is one of the ways we could find it. So we're being told that y equals mx plus 2 goes through the point 3 and 11. Normally, we would know a little bit more about our equation. So we would normally know the gradient and be looking for the y-intercept. Here, it's the other way around. So we can still, rather than using point-intercept form, we can substitute that point 311 into our equation to work out what that gradient is. So our value of y becomes the y value from the point. So 11 equals m, because we still don't know what that is, times 3, our x value, plus 2. So we'll subtract the 2 from both sides, gives us 9 equals 3m, and then we divide by 3. So our gradient in this line equals m. So the line is actually y equals 3x plus 2. Example 2 is a little bit more abstract again. So we've got a family of lines with equations of the form y equals mx plus 2, and we know that our value of m is always going to be a negative number. A is asking us to find the x-intercept of a line in this family. So we're going to end up with something that's x equals, but it's going to be in terms of m. So we're not solving for m. We don't know what m equals. We're literally leaving it as the letter m. And remember, our x-intercept is going to be where y equals 0. So we're going to say 0 equals mx plus 2. Negative 2 equals mx. And we want x by itself because we're finding the x-intercept. So we're going to have negative 2 over m equals x. So we know that our x-intercept in every line in this family is going to be at negative 2 over m, whatever our gradient happens to be. For part B, we want to know which values of m is that x-intercept greater than 3. So basically, we want to know when is negative 2 over m greater than 3. So we're looking at our inequalities here. We're going to multiply both sides by m, but remember that m is a negative number, so that's going to flip our sign. So we've still got negative 2, but now that's going to be less than 3m. And then we would divide both by 3 because we want m by itself in this case. So we have negative 2 over 3 is less than m. So those are the values. When negative 2 over 3 is less than m, then our x-intercept is going to be bigger than 3. However, remember that because m is a negative number, m is always going to be less than 0. So we need to add an extra parameter in there that m is less than 0. So what this now says is that our value of m is between negative 2 on 3 and 0. And for part C, we want to find the equation of the line perpendicular to y equals mx plus 2 at the point 0, 2. Remember, our gradient for a perpendicular line is going to be a negative reciprocal. So we know that gradient 1 of our original line is just m. So gradient 2 has to be negative 1 over m. And from there, we can just use point-intercept form to work it out. So we could say y minus 2 is going to be equal to negative 1 over m times x minus 0. So y minus 2 is just going to equal negative 1 over m. So y equals negative 1 over m plus 2. That will be the equation of the perpendicular line. So there's some slightly more abstract examples with your straight lines. None of your rules change. It's just going to be a little bit more to think about, a few less numbers, a few more letters.